a railway engine mass of 120,000 kg towing a coach of mass 60,000 kg up an incline. Angle, we have angle sine alpha, and we have driving force, and we have resistance to motion on the engine, on the coach. Find acceleration and tension. Okay, so first of all we need to draw the FBD. So we have the coach, we have the engine, we have the weight vertically downwards, which can be split into W cos perpendicular to the slope, and W sine, which is parallel down the slope. Okay, parallel to the slope. And we have the resistance forces. So since it's going up the slope, the resistance is going down the slope. And we have the engine force, and actually we have tension here. Okay, now to find the acceleration, the fastest way to find the acceleration is to use sigma F equals ma for all. So FBD of all. So FBD of all, acceleration is going up the slope. So all the forces going up the slope is positive, down the slope negative. Of course, we don't care about the W cos, and we don't care about the normal reaction force because we already have the resistance forces. We don't need to use coefficient of friction or something. So this is useless, this is useless, useless. We only use the forces parallel to the slope. Okay, so going upwards is positive, so Fe is positive, and We sine negative, Re negative. Well, the T actually they cancel out, minus T plus T, and Rc negative, Wc sine negative, and this is FBD of all. We use the total mass, and we are finding A, so just divide both sides by the brackets, use the numbers, plug in the numbers. The engine force, this is the We sine, W is m times g, mass of the engine, gravitational acceleration, the value of sine, resistance force on the engine, resistance force on the coach, and this is the mass of the coach times g times the sine value, mass of engine, mass of coach, plug in everything, use a calculator, we get the acceleration. And now we need to find the tension. Okay, so for the tension we can use the FBD of the coach only or the engine only. So if we use the coach, it's easier because we only have 3 forces. For the engine we have 4 forces. So for the FBD of the coach, again up the slope is positive, so this T is positive, this is negative, this is negative. So T positive, resistance negative, W sine negative equals m of the coach only. We're finding T, so just add these two to both sides, move it to the right, plug in the numbers, mass of coach, acceleration we know before, resistance force on the coach, mass of the coach, gravitational acceleration, the sine value, we get the tension force. Okay, so in conclusion, with the units we have the final answer. At an instant when the engine is traveling at 30 meters per second, it comes to a section of track inclines upwards at an angle beta to horizontal. So the angle is beta now, different angle. Power is now 4.5 million. Constant speed. Okay, so the engine force is engine power divided by velocity. So we have the formula power equals force times velocity. And we have the total mass combined here. We have all the resistance forces. We still have the same resistance forces, and we have the W sine component. Again, we don't care about the cos component perpendicular to the slope. So since we have 0 acceleration, constant speed, we use sigma F equals 0. So the force up the slope, which is this force, which is this power, engine power over velocity, is equal to all the forces down the slope. So it's equal to resistance on the engine, on the coach, and the total W sign. We are looking for beta, so just subtract this from both sides, divide both sides by the brackets, and we use inverse sign, and then we plug in the numbers. This is the engine power, velocity, resistance on the engine, resistance on the coach, and the weight is mass times G, so mass of the engine times G, mass of the coach times G, and after we use a calculator we get the final answer. Alright, I'll see you again next time.